Okay, so before we start this, it's probably really important that we draw a picture of what is going on here. So you have the water. In the water is your boat. Over here is a dock. And what's happening is you have a rope that's attached from the boat to the dock. I also know that the dock is 5 feet above the water. All right, so now that the picture is done, what is actually going on here is that what we're talking about is taking this boat, and this boat is going to be moving closer and closer to the dock. All right, so that's the rate that we're talking about. How fast is this boat moving as it's getting closer and closer to the dock? Now let's go back and write down what we know. Again, are we given? So I know that the rope is being pulled, so we need to go ahead and give this some variable. We're just going to call that, in this case, R. The bottom of my triangle, I'm going to go ahead and call X, so that the rope is being pulled at a constant rate of 3 feet per second. So we know that dr dt is at 3 feet per second. What is our known information here? And that's going to be the Pythagorean theorem of our x squared plus 5 squared is going to be equal to r squared. And our last piece that I always talk about is what are we trying to find? And we want to try to find how fast the boat is traveling. So we want to find the rate of the boat, dr over dt. Meaning, again, how fast that boat is moving. And we are told that we want to know when it is a total of 10 feet from the dock. So we want to find dr dt when x is 10 feet from the dock. We're going to again start with our known equation, and we want to take the derivative with respect to time of all of it. So I am left with dx over dt. The derivative of x squared is 2x. Now the derivative of 5 is just 0. There is no variable there, so we don't have anything we need to write with that. And then we know that the derivative with respect to t of r gives us dr dt of 2r. The 2's we don't really need. We can go ahead and cancel those out on both sides of the equation by dividing both sides of the equation by 2. So I get dx over dt of x is equal to dr of dt of r. Now, we know a couple of things here. Going back to our given information, we know that dr dt is equal to 3 feet per second. So I can replace all of this with the fact that I know that is equal to 3 feet per second. The other piece of given information that I have is I know that x is equal to 10 feet. So I can replace that with 10 feet. What I don't have that I need is r. How do I find that? I go back to our known piece of information and solve that, knowing that x is equal to 10. I know that r squared is equal to x squared plus 5 squared. I know in this particular case that x is 10, so 10 squared plus 5 squared. So r is equal to the square root That's 10 squared. So that's going to be 100 plus 25, or r is equal to the square root of 125, or r is equal to 5 square root of 5. So now I can plug that in for r as well, and that goes here. So let's go ahead and finish this up. I have that dx over dt times 10 is equal to dr over dt, which is 3 feet per second, times r, which is 5 square root of 5. So finally, I can say that dx over dt is equal to, divide both sides by 10. And now I can say that I multiply everything I have here, which gives me 15 square root of 5, that's feet per second, divided by 10, or reduce that to 3/2 square root of 5 feet per second.